We're going to do two lessons in one. They're pretty much the same lesson anyway. Let's start with lesson 2. And we have all these detailed notes, and this is in Google Classroom, and I highly encourage you to read through them, look at the examples, get all the details that you need. But for right now, for the sake of condensing this lesson, making it a little shorter, let's just chop it down to this. Go ahead and write this down. What is probability? It's a fraction. And on the numerator, it's what you want, and on the denominator, it's the total possible outcomes. All right? So once again, probability is a fraction. It's what you want over the total possible. So if you're watching this from home, I would pause it and write that down in your notebooks, especially because it will be an open note quiz coming up. So knowing that probability is a fraction, obviously it could be a fraction, obviously. But you could take that fraction and then convert it to a decimal, and you could convert the decimal to a percent, right? I would also like you to write down like a number line and put 0 on this side and 1 on that side. If your decimal is close to 0, that's less likely that it'll happen. If your decimal is something like 0.99, that's very likely, more likely that it's going to happen. So obviously 0 is impossible. 1, it will absolutely happen without question, 100%. Okay, so let's actually go through probability. Okay, so I think we all know what a dice looks like, or a die looks like, right? Now, what if I said, what is the probability of rolling a 5 on this die? 1/6, right? It's a fraction, right? By the way, this is the notation. That doesn't mean p times 5. When we're talking about probability, the p means the probability of the number 5, and we're talking about a die. So how many sides have the number 5? One side only, right? So there's one side that we want out of the total possible sides. How many total possible sides are there? 6. So it's crystal clear that the probability of rolling a 5 is 1 out of 6, 1/6. Now you could change this fraction to a decimal, right? That decimal will be, if you divide 1 by 6, so yeah, when you do it on a calculator, a fraction is really a division problem. When you go 1 divided by 6 on a calculator, it'll be 0.16, and it continues, right? So your calculator might at the end round it up to a 7. If I told you write it as a decimal, round it to the nearest hundredths, this would be the hundredths, so that would change to a 0.17, right? 0.17, if I asked you for the nearest hundredth. So it all depends. But anyways, that's how you write it as a decimal. To write it as a percent, you just move the decimal 2 spaces over, and your percent will be 16.6%. Now, of course, we know that 6 repeats. If I were to have said write it as a whole decimal, then you would round this up to a 17. So it's about 17%. About 17%. Now, again, it could be written as a fraction. It could be written as a decimal. Or it could be written as a percent. Okay? So on the quiz, I'll let you know what we want, whether we want a percent, a decimal, or a fraction. And that's pretty much it for the first lesson. Before we move on to the next lesson, again, the decimal or the number 0 means that it's completely impossible. The number 1 or 100% means that it absolutely will happen. There's very few things that you could say absolutely will happen, right? Could anybody think of one of them in real life?
Something that will
absolutely happen. Guaranteed.
Everybody will die.
Everybody will die. Yep.
Me getting an
I mean, so yeah, 100% chance of us dying, yes, we will all die, right? It's funny, every class have said that, but that's a perfect example of something that's 100% that's going to happen. Now, sometimes we see these probabilities misused. For example, last week, true story, I was walking out to throw out the trash. It was 8:19 at night, and I looked up at the sky, and it was kind of cloudy. And I'm like, well, what's the chance of rain? So I asked Siri, and here's my screenshot of my cell phone. It's 8:19 at night. So right here, right now, at 8:19, it's cloudy. And then at 9 o'clock, it says 100% chance of rain. That's not right, you know, because like, who knows? And like, I'm like, that's absolutely wrong. There's no way that it could be 100% chance, because that's saying that for sure it's going to rain. So what did I do? I sat out there till 9 o'clock. It didn't rain. So yeah, I actually did it. So this is definitely incorrect. Now, what they should have said, like if they were really, really, really sure that it was going to rain, they could have done 99%, or really, really, they could have even said 99.9%. But once you say 100%, that's saying that you know for a fact that it's going to rain, and it didn't rain. So, yeah. Let's move on to the next lesson. I'm sorry, to the practice of this lesson before I move on to the next lesson. How many pieces are there total in the spinner? 8. All right, so why would they ask for the total? It's the bottom number of your probability fraction. Okay. So any one of these questions that with regards to probability, you're going to need that 8 in the denominator of your fraction. What's the probability of you spinning it and it landing on a gray piece? 1, 2, 3 out of 8. See, you want 3 gray pieces. You want 3 gray pieces out of the total 8. So 3 out of the total 8. Now, of course, you could change that to a decimal. You could change that to a percent. What's the probability of it landing on a white piece? 1 out of 8, right? Now, this last one's pretty cool. It says, what's the probability of it landing on either a gray piece or a white piece? Either or, it doesn't matter. So what do you want? You want either a gray or a white. You want either one. So how many are gray and white? There's a total of 4. So 4 out of 8, that would be 1/2, right? So 4 out of 8, that would equal 1/2. Of course, you could change that to a decimal, 0.5. You could change that to a percent, 50%. Cool? We have more questions on rolling a die right here. If you were to roll a die, what's the probability it will not land on 3? In other words, you don't want it to land on 3. Yep, 5 out of 6. How many sides don't have 3? There's 5 out of the total 6. So there's the probability. Down here, it's a little more interesting. What if I said, what's the probability of me randomly putting my pencil on this paper and it landing on a circle on this diagram?
16.
First of all, how many circles are there? There's 6 out of the 16, so that would be your answer right there. And this one's for number 10. That's 6 circles out of 16. And of course, you could reduce this to 3 out of 8. Okay? And of course, you could change all these to decimals by dividing with the calculator. 3 divided by 8, that'll give you a decimal. And you could change them to a percent by moving the decimal over 2 spaces to the right. Anyway, I hope we get that. We're going to have these types of questions on the quiz. Let's move on to compound probabilities. Good question. On the quiz, I'll be very specific of how I want the answer. I could tell you, give me the probability as a percent of rolling the number 3, you know, so you would first write it as a fraction, then change to a decimal, then change to a percent. Or I might say write it as a decimal. I might say write it as a decimal rounded to the nearest tenths. I might say just leave it as a fraction, right? If you look at the answers right here that were provided, they don't even write them as fractions, and they don't even reduce them. Like number 5, 4 out of 8, they could have reduced that to 1 out of 2, but they didn't. They did not write it as a decimal, 0.5. They didn't write it as a percent, 50%. I want you to practice that though, because I will be asking different things on the test, and I'll be specific on my instructions. So look at this lesson number 3. Man, that's a great page of notes. I would like you to read through these when you have time. Check out the examples, really understand it. But again, for today's sake of making this smaller and faster, we're going to jump to some condensed notes. Everybody write down compound probability. And as you're writing down compound probability, what does the word compound mean?
It's a mixture.
A mixture, it's multiple, it's
A mixture of two or more.
put together, two or more, right? If you think of, let's say, a compound fracture, that means that you broke your arm in two places, right? So more than one, right? So we're talking about compound probability, more than one probability together. So compound probability is probabilities that are working together, or two probabilities together. Now there's two types of these compound probabilities, and it might be more than two. It could be 3, 4 probabilities together. So there are two types of compound probabilities. There's independent events that happen in a compound probability, and there's also dependent events that happen in a compound probability. Now, what is an independent event? It's something like this. If I asked you, what is the probability of rolling a die at landing on the number 5 and also flipping a coin and it landing on heads? That's a compound probability that's independent of each other. Okay, now what do I mean by that? Let's actually work this out. What is the probability of rolling a die and it landing on the number 5? What is that probability? 1/6. Again, probability of rolling number 5, that's one side out of the 6. Okay? Now, how about flipping a coin and it landing on heads? 1 out of 2, right? Or 50%, right? But I'm going to write down the correct notes. Probability of heads, that's 1 out of 2. Now, we're talking about a compound probability, so I need to put these probabilities together. And how to put them together would be with multiplication, not with addition. All right, we need to multiply them together. So what would the answer be? 1/12. So that's not that likely for it to happen. Flipping a coin, it landing on heads, and also rolling a die and it landing on the number 5. It's not that likely to happen. The probability is 1 out of 12, or you could change that to a decimal, dividing 1 by 12, or you could change it to a percent by moving that decimal over 2 spaces. But I guess at this moment I want to emphasize the word independent, because if you roll a die and it lands on the number 5, who cares? It has nothing to do with flipping a coin and it landing on heads. Make sense? Okay. Now, let's look at a dependent event. There's a bag of marbles. There's 2 black marbles, 3 blue marbles, 3 and 5 red marbles in this bag. You can't see the actual marbles. You stick your hand in and you want to select 1 blue marble, and then without replacement, that means you keep that blue marble out. You don't put it back in. Without replacement, you want to select one more blue marble. Okay, so let's go through this and work through this together here. Let's find out the probability of selecting 1 blue marble. Probability of blue. So what is the fraction that represents the probability of blue? What do I want? 3 out of the total 10. Does that make sense? So that is the probability of us selecting a blue marble. Now, imagine that. I reach in a bag, I pull out that blue marble, and without replacement, that means I don't put it back in. Without replacement, I want to pick out 1 more blue marble. So the second probability, another blue. Man, that's ugly. I apologize. But what is the probability of another blue if I pulled out a blue already and I put it to the side? How many blues are there now? Now there's only 2 blue. And how many total do I have now? Only 9. Does that make sense? So this is why we call these dependent events, specifically because without replacement. Specifically because without replacement. If I would have said with replacement, then you would have picked your blue marble, 3 out of 10, and then you put it back in, shake up the bag, pull it out again, and it'd be another 3/10, right? But because it says without replacement, that means that these guys are dependent on each other. If you pulled out one blue marble, then that second one changes. It's dependent on what you did the first time, right? If you pull out a marble on the first one, then it's no longer 10, now it's 9. It's dependent on what you did on the first one. Without replacement, they're dependent. Okay, but anyways, we're still not done. We now need to find this compound probability of 3/10 and 2/9, which is 6/90, which you could reduce by 3 or by 2 or by 6. You could even reduce by 6. Reducing by 6, I think it'll be 1/15. Correct me if I'm wrong. I think 90 divided by 6 is 15. So yeah, the probability of you picking a blue marble, putting it to the side, reaching in that same bag without replacement and pulling out a second blue marble, that'd be 1/15. It's not that likely. Of course, you could change that to a decimal, and you could change that to a percent. Okay. Let's take a look at the notes right here. Again, I would like you to read through these notes. Check out those examples. It's a great page of notes. Right here, just want to emphasize what we just said. If you have independent events, it occurs with replacement. Like if you take out a blue marble and then put it back in, you actually replace it. You put it back in, it's not going to depend on each other. Okay? With replacement, they're independent. They don't depend on each other. Without replacement, that's when you end up with a dependent event. It occurs without replacement. So if you pull out a blue marble and you put it to the side, now the number of blue marbles changed and also the number of total marbles changed. That's why those are called dependent events. Do you get it? Okay. So on the homework, our first part is just testing whether you understand independent events or dependent events. Let's talk about this one. Number 1, Anna draws a colored toothpick from a jar. Without replacing it, she draws a second toothpick. That's dependent. That's dependent. Bless you. Now, why is it dependent? Because I don't know if you're talking about like a red toothpick. She pulls out a red toothpick, then the number of red toothpicks change. There's one less now. And if you don't replace it, then the total number of toothpicks also changes. It becomes one less. So those are definitely dependent. The next one says, John rolls a 6 on a number cube and then flips a coin and it comes up heads. Those are independent, right? It doesn't matter if you roll a dice and it lands on the 3, it's not going to affect your coin. Or if you flip your coin, it's not going to affect your dice. So those are totally independent, right? Let's move on to, of course, you guys could continue practicing with 3, 4, 5, and you'll check your answers. The second part says, use the 2 spinners to find each compound probability. Again, this is the notation that says the probability of A and 2 both happening. All right? It's a compound probability of A and 2 both happening. So let me go over here to the spinners. The probability of A and 2. Let me write that down. P of A and 2. So that's really saying, let's find the probability of A, let's find the probability of 2, and then let's multiply them together. So what is the probability of spinning it and it landing on A? 1 out of 4. Times, what's the probability of spinning this one? That's totally separate, right? They're not even related. That's why they're not dependent. These are independent. Rolling or spinning it and it landing on 2. 2 out of total 6. Which will reduce to 1/3. Let me do that. 2 6, that reduces down to 1/3. And now, of course, we need to multiply them, which gives us 1/12. There's your answer of spinning it and it landing on A, and spinning it and it landing on the number 2. Okay, it's 1/12. Obviously not that likely. We could change this to a decimal. If I just divide 1 divided by 12 on a calculator, it'll give me the decimal answer. And you could move that decimal 2 spaces to the right, and that'll be a percent. So those are independent. Let's go to this next section that talks about that box with marbles of different colors. And notice that it says they are not replaced. So that means that these guys are dependent. All right? If you don't replace, the second probability that you do changes based on your first. So let's do number 10. Let's first talk about what's inside this box. Well, we have 3 red marbles, we have 6 blue marbles, and we have 1 white marble. So they want us to find the probability of blue and the probability of red, but keep in mind that there is no replacement. Okay, so let's first find out the probability of blue. What's the fraction that represents the probability of blue? 6/10. Okay, I'll reduce later. Right now, let's just leave it like that so nobody gets confused. How about the probability of red? 3/. Okay, because of the without replacement, this is now a 9. Does that make sense? Okay, so again, you put your hand in this box, you don't look at the marble, you pull out, you're trying to pull out a blue marble. Let's say you do pull out a blue marble. There's no more blue marble, and that total 10 drops down now to a 9, and you want to select a red marble the second time, and that's still 3 out of now 9. So both of these together happening, we'd have to multiply them, and what's our answer going to be? 18/90. Now, of course, we could have reduced them right from the start. 6/10 becomes 3/5, and 3/9 becomes 1/3, and that would give us a final answer of 1/5 because the 3's cancel. So the probability of picking a blue without replacement and then reaching in again and pulling out a red, that'd be 1/5, about 20% chance on this situation. How about the probability of blue and blue? Okay, so the first one's going to be 6/10 and then 5/9. Okay, now we're going to multiply. And you know what? Before multiplying, how about we reduce this first one? We could reduce it down to 3/5. Then you can multiply 3 times 5 is 15. 5 times 9 is 45. Or even easier, you could have canceled out those 5s and you get 3/9. Either way, it's going to reduce to 3/9. It's going to reduce to 1/3. So 1/3% chance. And looking at the solutions page, it's right there, 1/3. So I recommend practicing with this homework, checking your answers as you go. And why is it important to especially do this homework? Because I'm not going to have a practice quiz for you this week. You want to do your work. That way you could use this homework assignment, use however you show your work here, use it as a guide so when you're taking it on the quiz, you'll know what to do. Okay?